The advanced problem on Quideo number 4 says, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then placed in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. This data was used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Determine if there is a significant difference in growth between the tomatoes with additives and the tomatoes without. To solve this problem, you would need to use phantoms. Phantom stands for parameter, hypothesis, assumptions, name the test the test, obtain a p-value, make a solution, and then state your solution in context. For P, the parameter is difference in the true mean and growth of Roma seeds. And we would define this mean of difference, so like the mean difference equals mean difference in growth in inches of the seeds. For H, hypothesis, the null's hypothesis is the mean difference is equal to 0, and what you're experimenting is the mean difference is not equal to 0. So you're testing for if the mean difference is not equal to 0. And A is assumptions, and you're going to assume it's an SRS, simple random sample, and it states that it is approximately normal. And name the test. This is a one sample t-test, and it's one sample because they give you like one set sample of data, and it is a t-test because they give you a sample, so you have to use a t-test. And for T, which is to do the test, you have the formula x bar minus the mean over the sample standard deviation over the square root of n. And when you plug in the numbers, you get negative 2.015, which is like the value, which is the difference mean between the two, minus 0, and that's because your null hypothesis is 0, that it's equal to 0. The sample standard deviation is 1.163, and the sample is 12, so the square root of 12. You put this in the calculator and you get a t-score of negative 6.001, and you have a degree of freedom of 11 because your sample size is 12, so degree of freedom is n minus 1, which is 11. And you get a p-value by looking in the back of the textbook at the t-table by matching up negative 6.001 and 11, and then you can find the p-value is going to be less than 0.0005, which is really, really small. And for O, which is obtaining the p-value, we already did, which is p is less than 0.0005, and we chose an alpha value of 0.05 because that is the most average alpha value. And for M and S, which is make a statement and state it in context, we reject the hoe that there is a difference in growth of plants if the seed is treated with the additive, because the p-value of 0.0005 is less than the alpha value of 0.05. Therefore, we reject the hoe.